Hi, welcome to this video. We are going to start with chapter 6, Chemical Equilibrium. In the beginning of this video, we are going to look at the terms reversible reaction, dynamic equilibrium, which we already have the idea in experiment 5, law of mass action, which also can be known as expression for equilibrium constant. So there are two terms in K equilibrium constant expression. They are either Kc or Kp. For the reaction, it also can divide to two types, homogeneous or heterogeneous system. After that, we are going to look at what are the characteristics for the system which already achieve equilibrium. We will focus on the graph or the curve concentration versus the time. Then we have to know how to derive the Kp equal to Kc RT delta N equation. And then for the part calculation will be further discussed detail in your tutorial. There are two categories of chemical reaction. First is irreversible reaction. Second is reversible reaction. Now we focus on irreversible reaction first. What are the characteristics? First, there are one direction. So the reaction will be completely stopped once the limiting reactant is used up. These are the examples of the irreversible reaction. If we look at the chemical equation, one-way arrow is using, which is go to the right-hand side. So if we want to plot the graph concentration of reactant versus the time, we will notice the concentration of reactant is getting lower, and then at one point all the concentration of the reactant supposedly will reach the concentration equal to 0. If this is the graph that we obtain, so this reactant will be considered as limiting reactant. However, if there is excess reactant, so the concentration for the excess reactant and versus the time, you will notice the concentration also getting decreasing, but at one moment the concentration of the reactant will get static because the reaction is stopped. So means that the limiting reactant is used up. So there is excess reactant. Now let's look at the second category of reaction, which is reversible reaction. So look at the chemical equation, we will notice the type of arrow that used are different with the irreversible reaction. This arrow is called both-way arrow, which the reaction can go forward and at the same time the reaction also will go backward. So that's why we say there is two directions, and then the product can also react to give the reactant because it can be backward reaction. No reacting species is fully concealed. So this is the graph that we will get. Okay, this line will not touch 0. Okay, will not touch 0 because all the time both reactants and product are available. Now, let's look at what's the concept of the equilibrium or what are the characteristics for system which already achieve equilibrium. First, the forward and reverse reaction are equal. Second, concentration of reactants and product remain constant. So if you look at the graph below here, at this moment, the reaction is already achieved equilibrium. At the beginning of the reaction, so we know this one, the concentration, the rate of reaction is getting lower. So we know this one is referred to reactant. And the green line, the concentration is getting higher. So this one is referred to the product. After one moment, let's say at the T1, the rate of reaction to forward and backward are similar. At the same time, the concentration of reactant and product remain constant. And then to achieve equilibrium, the system or the reaction have to be happen in a closed vessel. Now let's look at the graph concentration versus the time. Generally, when we look at this is the reversible reaction. How we know? The arrow is both way arrow. Once we want to plot the graph concentration versus time, X will be represented as reactant because the concentration is getting lower, while Y will be considered as product as the reactant is getting more. So after the time at equilibrium, we will notice the concentration of X and Y does not change, but the concentration for both of them are different. The concentration are constant, but their concentration not necessarily similar. So means that after this time, the system is achieved equilibrium. So with the naked eye, you will think that the reaction is stopped because the concentration of both reactant and product are not changing, but actually at the same time the reaction is happen. So the intensity of the color will be remain. So for example, the concentration of the Y will be always 0.6, while the concentration of X will be always 0.4 after achieve the equilibrium. This is another graph to show the concentration of X and Y versus the time. In certain condition, the graph of X and Y will be intersect. But certain condition like this, the concentration of X and Y are not interchanged, but we can see here, start from here, around here, the concentration is remain constant. So this one is the time achieved equilibrium. So basically, the graph will be intersect or no will be depends on the initial concentration. Now let's recall again what are the characteristics for dynamic equilibrium or the system which already achieved equilibrium. Okay, by the way, before we continue, let's know what is the meaning of dynamic. Dynamic actually can be like considered from the word dynamo, which used in the bicycle, which they are always moving. Okay, so here I will consider dynamic as moving. So if means moving means that the reaction is not stopped. Okay, which means is continuously happen. Okay, now we look at the characteristic. First, again, closed system. Reaction is still in progressing, but then the concentration remain constant, like the three graphs that we show above. The rate of forward and rate of reverse reaction are same. Substance react to give products and also will reverse the reaction to return back to original reactant. And last, the equilibrium could be reached in either way. Means that sometimes the reaction will go forward to achieve equilibrium. Sometimes the equation may achieve the equilibrium by backward reaction. In this video, you can differentiate reversible reaction and irreversible reaction based on the type of arrow used in the chemical equation. Then you also can list down at least 3 characteristics for the dynamic equilibrium. And then you suppose notice there is 3 types of graph, concentration versus time. After went through this video, you supposedly can answer tutorial question number 1. So we will see you in the next video. Thank you for your time.